10,000 years ago, the first farmers domesticated wheat from a wild grass, a relative of Brachypodium. Now, just in Australia, our farmers produce around 25 million tonnes of wheat every year. That's a lot of wheat bix. I grew up on a farm and I've seen how agriculture has improved over the years. For example, back in the 90s, farmers jumped at a new technology that let them sow wheat straight into the stubble of a previous crop without ploughing first. This saved fuel and labour and reduced soil erosion. So it wasn't long until most farmers stopped ploughing before they sowed. But even today, some farmers can't make the change. And the reason is this fungus called Rhizoctonia, which attacks roots and causes these patches of stunted wheat in the field. Ploughing mixes crop residues into the soil. It's a bit like making compost. Soil bacteria go nuts over all the food and they gobble it up quick, leaving Rhizoctonia with nothing. So Rhizoctonia levels drop and you get less disease. Now, if you don't plough before you sow, Rhizoctonia levels stay high. You're more likely to get disease. But at least you know your topsoil isn't going to fly off to whoop whoop. So can we have both? Can we have good soil structure and low disease? What can we do? What we haven't been able to do is breed wheat that is more resistant to Rhizoctonia. To do that, it would be really useful to know which genes wheat can use to fight off the disease. But trying to find new genes in wheat is a bit of a nightmare because it basically has 6 copies of every chromosome. So my project is to look for resistance to Rhizoctonia in this wild relative of wheat, Brachypodium. Brachypodium only has 2 copies of every chromosome and its genes are sequenced. So finding new genes in Brachypodium is a lot easier than in wheat. I've washed and scanned and compared the roots of hundreds and hundreds of plants, and I found that some lines of Brachypodium are in fact more resistant to Rhizoctonia than others. Having this variation means that we can start looking at which genes Brachypodium uses to defend itself. And hopefully from this we can find these genes in wheat, and that'll help us to eventually develop wheat that is more resistant to Rhizoctonia, so that our farmers have an easier time caring for their soil while they're growing our breakfast.